Hi guys, Mr. Hescox back again, checking in. We are going into the third section of chapter 4 on types of evidence of evolution. Your warm-up question is, what is a fossil? A fossil is the preserved remains of an organism in the earth, whether it's ice, sedimentary rock, or amber. So evidence for evolution starts with the fossil record. So the fossil record is if we took all of the fossils and we put them on a timeline. And that timeline shows us when things arose on Earth and when they disappeared from Earth. There have been 7 mass extinctions on Earth. A mass extinction that's most famous is when the dinosaurs went extinct. It is not the Jurassic Park type dinosaurs, but these are the ones that were actually during the Cretaceous. What was good about the dinosaurs going extinct? We mammals, such as us, dolphins, whales, bears, deer, anything with fur, were basically able to take over the Earth and become the dominant life form. Yay, mammals. One of the most complete fossil records of organisms that we have today is this dog-like organism called Eohippus, which is actually the earliest ancestor that we found of the modern-day horse. Here is a picture of Eohippus. He had 3 toes that would spread out. We believe that Eohippus was in a very wet environment, and by spreading its toes, it may have even had webbing between its toes. That spreading out helped it to stay up on the mud and may have helped it get away from predators. Next example of evidence of evolution is what we call homologous structures. Homologous means the same. So these are structures that are very similar or almost the same, but may not have the exact same job. So if you look at the forelimbs or the front limbs of a human, here's our upper arm, the radius, the ulna, all of these are your fingers. Look at the cat. The cat has very similar bone structure in its front paws, except for it doesn't have the fingers. If you x-ray the whale's flipper, the flipper itself is mostly the same type of bones that our fingers are. And the bat even looks like it has little toenails or fingernails at the end. The more similar the bone structure, the more similar the organisms are, the closer they are as far as terms of evolution. Vestigial means reduced and unused. We have a tailbone. We don't actually have a tail. We have an appendix that doesn't work. We actually have that little membrane on the inside of your eye that doesn't work. All of those are used maybe thousands of years ago. Like the appendix in dogs actually prevents them from getting sick from eating rotten meat. We cook our food. I know that some of you are probably getting to the point where your dentist is worried about your wisdom teeth. Wisdom teeth were found in humans back when we had to chew our food a lot more. Now they're not used as much. In fact, I personally only had 2, and not everybody even gets them. So some of them are actually being so unused that these vestigial structures aren't even showing up anymore. Other examples, if you x-ray a snake, you can see where the legs, there's tiny little bones that used to be leg bones on a snake, or even hind flippers on a whale. Radioactive dating is used to age fossils. Now we can look at the layers of rock, and we call that the law of superposition, or we can use radioactive dating. Basically, they take a sample and they compare the amount of a radioactive element to what it decays into. So one of the most common radioactive dating is carbon-14. If it's really, really old substances, they may use uranium-238 dating. All right, ladies and gentlemen, that's Mr. Hescox. We're talking about evidence of evolution. I hope you have time to, if you have to, watch this again. I'll be seeing you next time. Get your work done and have a great day.